Alright guys, today we're going to start with Chapter 6, and all of Chapter 6 deals with different types of polygons. We've already talked about triangles just a little bit, and we're going to extend those triangles into all the other polygons that we know about. Section 6.1 is on the polygon angle sum theorems. We have a couple different theorems about the different sums in the angles, and your objectives for the day is we want to be able to find the sum of the measures of all interior angles and basically the exterior angles of a polygon. So finding measures of interior and exterior, either one of any kind of polygon. Okay, so we have some given shapes here. We all know that this triangle, the sum of the measures of a triangle, should be 180. So sum is 180. And we know that that works for any triangle. So basically we can take these tough shapes, and let's say if I just break this down and go sort of across the corner here, what I've done is I've essentially made two separate triangles. Well, for those two different triangles, we just add up the 180 and the 180, and that gives me 360 degrees for every angle in this shape. So if we add up all the little angles on the exterior of it, which would be the original outside of the shape, that would equal 360. Alright, let's keep trying. So look at our next shape here. We have, what is this? This is a pentagon. And on a pentagon, seeing how many triangles we can make out of it, we could extend from here to here. We could extend from here to here. And we see we have 1, 2, 3 triangles. Each triangle has 180, so I'm going to do 180 times 3, and I get 540. So every pentagon will have 540 degrees. Alright, continuing on with these next ones. You can keep doing this same pattern to make triangles. Just start from one vertex and draw off a little triangle. Keep drawing from that same vertex to the other vertices. So we can see here we have 1, 2, 3, 4, 5 triangles. This was a heptagon, by the way. 5 times 180 is 900 degrees. And seeing how many triangles we can get out of this shape. There's 1, 2, 3, and 4. So we have 4 triangles out of that shape, and 4 triangles at 180 apiece would be 720 degrees. Now, how I got each one of these again, for this one it was 1 times 180. For this one it was 2 times 180. This one was 3 times 180. This one was 4 times 180. And this one was 5 times 180. Now, referencing these numbers, we can see that a pattern is occurring. And to get, this is a triangle which has 3 sides, and we went down to 1 times 180. This is a quadrilateral, which would be 4 sides, and we went down to 2. This was a pentagon, which was 5 sides, and we went down to 3. This was our hexagon, which is a 6 side, and we went down to 4. And then, like we said, lastly, we had a heptagon, 7 sides. We went down to 5. And you notice every single time, an easy way, basically a little formula for us, is we can take the number of sides, subtract 2, and times it by 180. And that will tell you how much the interior angles in any polygon sum to. Alright, and that's actually our theorem. The polygon angle sum theorem. It says the sum of the measures of interior angles of an n-gon, so this is any sided polygon, is n being the number of sides minus 2 times 180. So simply number of sides minus 2 times 180, and that's our polygon angle sum theorem. And basically the reason we can use that and the reason we can get that is we're just, n minus 2 is finding the actual number of triangles. Alright, example 1 here. What is the sum of the interior measures of a 17-gon? We're simply going to use our formula and say the sum equals the number of sides minus 2 times 180, which will be 17 minus 2 times 180, which is 15 times 180, which is 2,700. So there's 2,700 degrees in any 17-gon. Alright, and basically same type of problem, but with them changing it on us just a little. It says the sum of interior angle of measures is 1980 degrees. How many sides does the polygon? So they're giving me the answer, and they want to know how many sides. So we're still going to use that same formula. Sum equals n minus 2 times 180. I know the answer, so I'm going to plug in 1980 equals n minus 2 times 180. The easiest way to get rid of this first is actually to simply divide by 180 on both sides. And then 1980 divided by 180 is 11. So 11 equals n minus 2. Let's finish up solving my equation. I'm going to add 2 to both sides. And n is 13. So how many sides does the original polygon have? It would have 13 sides. So basically that formula, we can either be given the sum and we have to find the number of sides, or they'll give us the number of sides and we have to find the sum. And that's the first type of problems we're going to work today. A little more vocabulary. Remember, equilateral means all sides are congruent. So any polygon with all sides congruent, you can see our congruent marks on the sides. Equiangular means all angles are congruent. So there's all sides. And by definition, when I call something a regular polygon, it means that both equilateral and equiangular. So just by saying the word regular, you can automatically assume that all sides and all angles are congruent. Alright, we have a corollary to the polygon angle sum theorem. And basically what this is telling me is the measure of an interior angle of a regular n-gon is the same formula that we dealt with, but they're dividing it by n. It's basically like they're averaging it. So that basically you just say, alright, find out how much total we have, and then we're going to divide it by how many angles we have, and that gets how much each one would be. And remember, that only works if it's regular, where they're all equal. Alright, example 2 then. What is the measure of the interior angle of a regular nonagon? Well, first we've got to remember how many sides is a nonagon. It's got 9 sides, so we need to find the sum first using our formula here. We can say the sum equals 9 minus 2 times 180. That means that's going to be equal to 7 times 180, and 7 times 180 is 1260. So that's the sum of a nonagon, but we're finding each angle, so that means we need to divide by the number of sides. And that'll mean each angle is 140 degrees. So you see how these problems are worded very similar with each other. You've got to look at that each angle, or what is the total sum, and that's the only difference between them. Alright, using this same type of information to solve an actual problem, what is the measure of angle G in quadrilateral EFGH? They've given us some of the information. They've not gave us one piece. We have to remember that Okay, we need to find out how many degrees are total in this shape. Well, this has 1, 2, 3, 4 sides, so it's a quadrilateral. If we didn't remember how many degrees were in a quadrilateral, we'd use our sum formula, and we'd say n minus 2 times 180. Well, it's a quadrilateral, so it's going to be 4 minus 2 times 180, which is 2 times 180, which is 360 degrees total. I'm going to subtract the 120 that's in the shape. I'm going to subtract the 85 and subtract the 53. And so I'm going to take out my total number of degrees in this shape, 360 minus 120 minus 85 minus 53, and that leaves me with 102 degrees. And that's what angle G has to be. Has to fill out the rest of the shape. Alright, moving on to these now. Let's say we have an equilateral triangle. All sides are equal. That means these are 60 degrees, 60 degrees, 60 degrees. These exterior angles here, that would have to be 120 degrees because it's a linear pair. This would have to be 120 degrees because it's a linear pair, and this also. If we add these together in the triangle, 120 plus 120 plus 120, we get 360 degrees for the exterior angles in a triangle. Let's try it again with the square. This is 90, 90, 90, and 90. The other part of the linear pair would also be 90, 90, 90, and 90. And we add 90 plus 90 plus 90 plus 90, and again we get 360. This seems like an easier pattern. Alright, let's move on to our next shape. And this is what, a 1, 2, 3, 4, 5, 6-sided shape. So we have a hexagon. And remember, the hexagon would be 6 minus 2 times 180 divided by the number of sides to get each one of these angles. That would be 4 times 180, which is 720 divided by 6 would be 120 apiece. So these are all 120, which would make these the other part of the 180, or 60, 60, 60, all the way around. And so that would be 6 60-degree angles, which is 360 degrees. That moves us to our next theorem. Theorem 6.2 is the polygon exterior angle sum theorem. And building off what we just looked at, the sum of the measures of the exterior angles of a polygon at one at each vertex is 360 degrees. Every single time, I don't care how many sides are on it. Alright, example 4, what's the measure of an exterior angle of a regular nonagon? So it's looking for the individual angle in this case. Well, a nonagon we know has to have 360 degrees total for all the exterior angles. And a nonagon has 9 sides, so if we divide that by 9, 360 divided by 9, we get 40. So each angle in a nonagon will be 40 degrees for the exterior angles. Okay, so we can take any shape, basically, no matter how many sides it is. Let's say a 10-sided shape. We would still do, if I want to know each angle in the 10-sided shape, so a decagon, we would do 360 divided by the number of sides. That'd be 36 degrees apiece. Alright, so that's a nice quick shortcut to get the exterior angles. Alright, that is the first lesson. Here's your assignment, page 356, numbers 7 through 25, and 29 through 36. If you have any questions, feel free to tweet me and I'll try to get some replies to you.